All right. So now we're doing FreeCodeCamp Legacy Python for everybody. Iterations, more patterns. All right, so let's get to this. This one has an exercise too, but we'll do that in the next video. Let's get to it.
So now we're going to look at some more patterns.
Okay, I always forget. Let's write this down first. All right, so let's get out the notes. Boom. Here we are at the beginning. This is a continuation of chapter 5. I'm saying that because ChatGPT writes all my descriptions. You know, you should know this by now. Counting in a loop. So what we're going to do here is type this down. Zork. I think that's exactly like this thing. So let's come up here and take all of this. Let's go from here to here and just replace some values, right? So let's take this, copy that. And down here, after continuing counting in a loop, let's drop this off. All right. So let's see. We're going to turn this into Zork. All right. So largest so far. Can we double click it? Yes, we can. We'll call it Zork space. All right. Then print before we'll go Zork right here. Let's double click Zork like this. Actually, let's just highlight this. Yeah, like that. Double click largest so far. Come on now. I don't know what that's all about. Double click that. No, highlight that. Drop it off anywhere where you see largest so far, because I think it's going to go. Honestly, I don't know what the thing is. Let's do this. Largest so far. Oh, yeah. I don't know what it's thinking. Right here. All right. Zork, 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 Zork. This looks stupid now. Tab, 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 tab. All right, so we got that. For thing in, let's call this thing. Thing. All right. Wait a minute. Yeah, we're still here. Let's take this thing, copy that. And I think we just need to change this, the num, and this one. So let's change this one and this one. And let's tab this over. Tab, tab, tab. All right. So Zork equals, all right. So now if, we don't need the if statement now. This is part of it. This is honestly, this is literally part of coding. Taking something you made before and turning it into something that you can use again for something else, right? This is literally something that we do. So let's take this, get rid of it. All right, bring this up. Oh, that's going to be a problem. We'll fix it later. Let's bring this. Let's get rid of this too. Bring this up one like that. For Zork, let's tab it over one. Print. All right, we're going to say for Zork equals Zork plus 1. Let's say Zork for thing plus 1. That's not it. So we've got that. Here's these numbers. That thing's cool there. Print Zork thing. Yes. Print after Zork. All right, cool. All right, so let's see this. So we're going to have Python count loop.py. Let's call it that. Count loop.py. Before, we're going to have this 0. All right, so it's going to print before 0. And then Zork. Okay, so we're doing Zork. We're saying 1 plus. All right, we're saying Zork plus 1. So Zork is 0 first because we're printing out Zork and then the thing. All right, so before 0, before Zork equals 0, then we're doing 1. Let's not look at this. Let's change all this actually. Let's go like this, like this, like this, since they're all different pretty much. And then this. All right. So let's look at this. So we're going to print. So Zork's going to equal 0 to start off with. Let's change this to 0. All right. So first we're going to print before and Zork. So before and 0 because Zork equals 0. And then for thing in this list, we're going to say Zork equals Zork plus 1. And then we're going to print Zork and thing. So the first time it goes through, Zork is 0 plus 1. Space this. So now Zork is 1, right? So now we're going to print Zork, which is 1. And we're also going to print the thing, which is 9, all right? And this is the first thing, all right? Then we're going to go through again. We're going to say Zork plus 1. So now it's 2, all right? And we're going to print out 41. So this is 41 and whatever. You get it. So we've got 3 now because we did Zork plus 1, and now we're printing out 12, right? So we're on this iteration of the thing, and we're printing out 3, right? Just like before. And then we're doing it the same 4, 3. Then we're going to have 5, 74. All right, good. And then we're going to have 6 at 15. And then we're going to say tab, 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 tab. We'll say now it's going to print after because 6 is the last one. 15 is the last one. We'll say after. And then we're going to say Zork right now, which equals 6, right? So that's how that counting for loop works. Let's see him. Let's listen to Dr. Chuck say it.
So now we're going to look at some more patterns of the different things we can do at the top of the loop, in the middle of the loop.
Hold on. I didn't type that part down. All right, so let's type that part down, that last part down. Let's say hyphen space to count how many times we execute a loop, comma, we introduce a counter variable. That's what the 0 is. That's the counter variable. And we're going to have it that starts at 0 or wherever you left off when you were counting before. Who knows? We're going to and it starts at 0 and we add to it each time through the loop. All right. Honestly, I don't know why this list is here. I think it's because we haven't talked about the range thing. Like in Python, there's like a range thing from 0 to 50 or whatever. But since we haven't talked about that yet, we'll do that later. We're just going to do this list style. Okay, we've got that going on right there. And let's listen to him say it.
Loop and at the bottom of the loop. So now we're going to look at some more patterns of the different things we can do at the top of the loop, in the middle of the loop, and at the bottom of the loop. And the first one we're going to do is counting. Now we're going to take a look at the number of something, the number of things in our list. Now we could just inspect it and see 6, but you will have for loops like you're reading through a file or scanning through some data. And so the notion of counting, you have to assume that you don't really know, that there's going to be a lot more than just 6.
Yeah, he's talking about like if there's like 52 million of them, like the literal number, 52,500,063 files. You know what I'm saying? That's what he's talking about. Because, I mean, of course you can see 6, but if the number's huge, that's what the computer's for. Let's go.
But for now, we're just going to do 6, and we're going to count how many things that we see in this loop. And the pattern is simple. You set a variable, Zork, to 0 at the beginning. We often call this variable count in mnemonic. And now we're going to run this loop 6 times. 1, 2, 3, 4, 5, 6. And each time through, we're just going to add 1 to Zork. So Zork starts at 0. Then it goes 1, 2, 3, 4, 5, 6.
True.
And we're going to print it out. So, we see the 9 and Zork is 1. See 41, Zork is 2. And Zork is 16. When we see the 15, 4 stops. And we print out afterwards, and this then is 6 is then the ultimate count that we got. So that's very, very simple. The pattern is
very simple.
Set it to 0 at the beginning, add 1 to it, and if you run that enough times, then this is how many times that happened. And in a sense, it's,
as you can see, like it is really simple. But I mean, talking about it, learning how to say this stuff, that's what's hard. How to explain this. This is real simple. Set Zork to 0, print before. Okay, let's say we're talking to the computer as if it can hear you, right? Or let's say we're talking to somebody that's actually doing this stuff, all right? Set Zork to 0, print before, and then what Zork is. Then after that, for this list I give you, type 1 in between, 1 in front of it, type the, anyway, you see how hard it is to say this stuff. I can't even say it that easily, but whatever, let's go.
It's how many times this line ran. Right? Sometimes you put this in an if statement, et cetera, et cetera, et cetera. Okay? Oops. Now, we can do the same thing to get a total. The way that
let's do this. It's the same thing, but we're going to change it. Zork plus thing. Oh, yeah. All right. Let's come over here and let's make that happen. All right. So now let's take this. What are we calling this? Summing in a loop. Okay. Let's do that. Summing in a loop. So let's take all this. We're going to delete this stuff. Boom, down there. Oh, come on. All right, let's take this up to right after counting in a loop, all right? Now let's come down here right after summing in a loop, drop it off like this, right? So let's change this stuff up. What are we calling this? Count loop.py. Okay, so it's still count loop, but whatever. He did copy and paste also. Let's get rid of this, and wouldn't you know it, this too, right? Before 0 can stay there, right? So now we've got Zork equals 0. We're going to print before Zork, just like that, right? So just like before. For thing in this list, we're going to say Zork equals Zork plus, instead of Zork plus 1, we'll say Zork plus thing, all right? So first it's 0, all right? And then when we do the first thing, it's going to be 0 plus 9. So we're going to say print Zork, which is 9. That's the place. That's 0 right now. Pardon me. It's 9 when we add it to it, right? Zork is 0 plus thing. Thing is 9. So now Zork is 9. And then we're going to say thing is also 9, all right? So now we're going to come down here and we're going to add Zork to thing. So Zork right now is 9. I really hope this thing's not skipping up on me. All right. We're saying Zork is 9 and thing is 41, right? So 9 plus 41 is going to be 50. So we're going to print out 50 and 41, which is the thing we're at, right? So let's come to the next line and we're going to print out, where are we? All right, right here. Okay. So we're going to print out, we're going to add Zork to thing. Zork right now is 50 plus thing, which is 12. All right. So 50 plus 12 is going to be 62. We're going to have 12 right here as the thing. So we're going to come down here and we're going to add 62 to 3. So we're going to have 65. 65 and the thing is 3. And then we're going to have 65 plus 74, which is going to be something 9. 65, 139. Yeah. 139 and 74 right here. And then we'll come down here and we're going to have 139 plus 15, which is, I'm just looking at it, 154 and 15 right here. And then we'll print out after. It's going to be 154, right? So we're adding each one of these together. Look at this. Look at this. You see this? This is what I'm dealing with. I think I need to upgrade computers. Anyway, we're just adding each one of these to the running total, right? So let's come down here and let's type up what this says. So to add up a value, we encounter in a loop, we introduce a sum variable that starts at 0, right? And we add the value to the sum each time, each iteration, let's put it like iteration through the loop, all right? So to add up a value we encounter in a loop, we introduce a sum variable, and that's what we did right here. We would usually call this sum instead of Zork, that starts at 0, right? And we add the value of the sum, the value to the sum each iteration through the loop. So it's going to start 0 plus 9 plus 41. We just did it. You know what it says. All right, let's listen to him tell us about it. You know how it goes.
The total works is you compute a running count. We can do the same thing to get a total. And the way the total works is you compute a running total of the number of the items that you've seen so far. And at the end, the running total, in effect, becomes the total. A better variable name for this would be like sum or total or something, but Zork, I'll use Zork again. So you set Zork to 0, and it starts out, the total we've seen so far is indeed 0. And then we're going to run this 1, 2, 3, 4, 5, 6 times, and thing is going to be the iteration variable. It's going to take on the successive values, and each time through we're just going to take our running total and add to it the thing we've seen. So we see 9 and the running total is 9. We see 41 and the running total becomes 50. We see 12, the running total becomes 62. We get a 3, it becomes 65, we get 74, running total is 139. How many more are we going to see? We don't know. Could be a million, could be 1. Oh, it's only 1. We get a 15, our running total is 154. And what's true at any moment here is the running total is right of what we've seen so far. Now, when we're done, the for loop quits for us, and afterwards 154 is indeed the total. So the running total while we're in the loop, at the end of the loop, after the end of the loop, we have the actual total. So it's not very difficult to convert this to the average, because we've calculated the count and we've calculated the running total, and now we're going to have the average by simply dividing those. Okay, so
all right. I mean, look at these chumps. Look at these scrubs. They could have had anything else, but they had to do it. That's who we're dealing with, guys. They just can't help themselves. They're like, hey, how about this? We're into this kind of stuff. Hey, do you got kids? And that's what they literally into. All right, and it's 18 minutes, so this is gonna be like an hour long. All right, so let's go. What a piece of. All right. We could just turn any of these numbers into something else. What a piece of work. You know what I'm saying? All right. So what we're going to do is count 0. All right. We're changing these to regular counts and sums now. So let's take this stuff from here to here. Look, I used to, back in the day, I would have just quit. I would have said, go to hell. But the thing is, they're going to hoard, as long as they keep throwing this BS around and people like me say, oh, I'm just going to boycott you because of this. They're going to still hold on to all the information when it comes to coding. So we have to push through this nonsense, and then we're going to come and say, hey, remember what you did? Anyway, that's just the way I feel. All right, let's come down here and say finding the average in a loop. All right, let's paste this. I already copied from 154 to up here while I was ranting. And I'm going to paste right there. There we go. All right. So we're turning Zork into count. Let's just get rid of all this stuff right here. We can keep. No, we're going to change that too. So we'll just take all this and get rid of it. I don't want to fast forward. I don't want to go in and say, okay, fast forward this in editing. All right, there we go. All right, so plus we're going to, whatever. All right, so we're going to change the Zork now is, let's call it, let's call it count. Let me say count. We'll call it Zork is now sum. All right, let's put a space in between the boom. Count equals 0. So we're adding both of these together, the count and the sum. I mean, when I say add them together, we're having them both in the print statements, all right? So we're say print before, and then we're going to say also print count and sum. All right, so print before, print count, and print sum. They can't help themselves. They just can't. Every time I look at that, I'm just like, you dogs. You barking dogs. Count equals count plus 1, right? So just like the count thing where it's, it was Zork plus 1, now it's count plus 1. Now we're going to also add another one, and we're going to say sum equals sum plus, and we're calling this value now, right? So let's call value in this value. So sum plus value, all right? So now we're going to print count, sum, and value. Count, sum, and value. All right, let's get rid of this. And then we're going to print after. Let's get rid of this. Let's print after, and then we'll take these and replace this Zork thusly. All right, so count, sum, value, and then the average as well, which would be what? What? Count, sum. Oh, yeah. Sum divided by the count. So sum divided by the count. All right. And that would be the average. True. All right. So let's do just that. Let's look at this thing and do that. All right. So we're going to start off here on the count line. And we're going to print out, let's start on the one above count. 2, 3, 4, 5, 6, 7. There we go. All right. So we're going to start off by calling the program. We'll say $Python average loop.py. Average loop.py. All right. We're going to come down here and we're going to say, so the first thing we're going to do is print before, right? That's what this before is. So we're going to print before. And then we're going to print count and sum. So right now count is 0 and sum is 0. So we've got 0 and we've got 0 right there. So let's go to the next line. All right, so now for value, for each one of these in order, for value in this thing, in this list, we're going to say count equals count plus 1. Sum equals sum plus value. Yes. And then we're going to print count, sum, and value. All right, so we're going to print the count first. So the count is count plus 1. So 0 plus 1, 1. Boom. Sum is going to be sum plus value. Sum is 0 plus value is 9. So we'll print out 9. And now we're also going to print out the sum, the value. Okay. We're also going to print out this value right here. So 9. So now on the next line, we're going to come down here and we're going to print out count. So count is now 1 plus 1. So that's 2. All right. Sum is now, and we're going to be typing down sum. Sum is now sum plus value. So the sum was 9. The value is 41. So now we're typing out 50. All right. So the sum is 50. The value was 41. All right. So now we're on the next line. So we're doing the 2 plus 1. All right. This 2 plus 1, which is 3. All right. And then the sum, which is the count, which was 50. Pardon me, the sum, which was 50, plus the value, which is 12. So 62, right? And then we're going to say the value is 50. The value's not 50. The value's 12. All right? So there's that. So now we're going to come to the next iteration of this, and we'll say 4 because count plus 1. Then we're going to do sum, which is 62, plus the value, which is 3, so 65. And then the value is 3, right? So down here, we're going to say count plus 1, which is 5. We're going to say 65 plus the value, which is 74. And so we'll get 139. It could have been anything else. Honestly, it could have been anything that divided by 3 or divided by 5, but they chose to do what they chose to do. So we got 139 and the value is 74, all right? And then we've got right here 6, which is count plus 1. And then we're going to say 154, which is 139 plus 15. And then we're going to say the value is 15. And then we're going to print out after. And 6. All right. So it's printing out 6, which is the count. 1, 2, 3, 4, 5, 6. The sum, which is 154. And aren't these ints? Are these ints or are they floats when they start? Are these integers or are these floats when they start? Because if they're integers, they wouldn't do that. They would just say 25. They would round down, right? are these floats when they come in? I could have sworn they start as integers. And so because this is an integer, right? So this is actually new. This wouldn't even happen. This 0.666, this wouldn't even happen. It would just round down because it's an integer. So yeah, you see what we're dealing with. This isn't even what would happen. They just was like, oh, that's what they did. All right. So an average, watch this will stick it to them. Combines the counting and sum patterns and divides when the loop is done. All right. So an average just combines the counting and sum patterns. All right. So we've got the sum and the count, and then we'll divide the sum by the count when we're done. So the sum by the count, and that's it. All right. So let's listen to this hilarious guy talk about it.
I've used mnemonic variables. Don't get confused by this. Mnemonic variables are just friendly names I chose for you to read the code easier. I am not communicating to Python in any way by naming this count and sum, but count and sum is nice. Okay, so I set count to 0 and sum to 0. Oh, go back up. I set count to 0 and sum to 0 at the beginning, and the count is 0 and the sum is 0. And then I'm going to run this loop 6 times. 1, 2, 3, 4, 5, 6. And each time, value is the iteration variable. I count, every time I run the loop, I count equals count plus 1, sum equals sum plus value. So I have a running count and a running total, and they show up.
Is that what happens? Hold on. Let's go look at the internet. We are. What am I talking about? Is it full screen? Python. I'm gonna open up ChatGPT. Let's close this out. When Python does division, does it automatically convert ints to floats? Yes. Up. All right. So it would do that actually. Boom. So let's change this up so it doesn't make me so pissed off. All right. Sum plus count. Hold on. Let's get this. Int. Hold on. Let's ask ChatGPT. If I wrap a float in the int in Python, will it automatically round down? Okay. All right, there we go. All right, so that's what I'm doing. This is just to make me less pissed off. All right, so there, now it's going to be 25 because I'm not typing that. I don't care what these ritualist, disgusting child sacrificers want to do. I'm not doing that.
Up here, 1, 2, 3, 4, 5, 6, and then the running total. And then at some point, the for loop, we do the last one, and the for loop jumps out, and it divides 6, 154 is the count and running total, and then it divides the average sum over count. Okay? So that's just, again, a pattern of something in the beginning, something in the middle, something in the end. Another kind of thing.
All right, Anton LaVey. Let's go to the next one. All right. So filtering in a loop. All right, Anton. Filtering in a loop. So now we've got this new thing. Print before, we're going to have the same value thing, and we're going to do a different value. So let's just take this up to this 9. All right. from whatever the line this is with this 12 at the end up to this 9, right? Let's bring it down here like that. Let's bring it down one more. And then we're going to print before, and we're going to get rid of count and sum, all right? Get rid of this. Let's highlight it and press tab twice. And get rid of that. And then let's come down here and tab 1, 2 times and say if value is greater than 20. I liked it like that better. We're going to say print. We'll say large number. That's not how you spell large. Large number value. All right. And we'll come down here and we'll print after. All right. So what this is going to do is we're going to first start off by, let's see, this is on this line. So let's come down here. We're going to first start out by calling the program. We're going to say $Python search1.py, right? So that's the name of the thing. We'll come over here and say before. That's what it's going to print first. This first before, right? We'll come down here and now we're going to go through the loop. So for value in 9, in this thing right here, if the value is greater than 20, we'll print it, right? So it checks 9. It's not there. Large number. Oh, large number value. Okay. So we're going to print. So we're going to check 9. All right. 9's not bigger than 20. So we're going to skip this. Go to the next one. 41. 41's bigger than 20. So we're going to print the words large number 41. Right. And we're printing the value as well. Checks this one. Lower than 20. Lower than 20. 74. So down here, we see the 74 is larger than 20. Say large number 74. All right. And then we check 15 and it's no good. It's not larger than 20. And then we're going to print afterwards. All right. And that's how that loop works. Let's listen to listen to old Chuck talk about it.
We tend to do in loops is we look for things. We hunt for things. And
I think I've revoked his doctorhood, honestly, because look, the thing about the title doctor is it's conferred upon people by a group of other people. Therefore, if you decide that the person's not a doctor anymore, maybe other people don't believe it, but you yourself can't believe it. And this guy, after saying 666, you're no longer a doctor, buddy. You're just Chuck to me.
this is where we have an if statement. Look. Another kind of thing we tend to do in loops is we look for things, we hunt for things. And so this is where we have an if statement inside of a loop. And of course,
true. I didn't type this part down, so let's type that. All right. So we're going to type right here. We use an if statement in the loop to catch or filter the values we are looking for. We use an if statement, yes, in the loop to catch or filter the values we're looking for. True. I mean, that's basically it. So let's listen to him say it.
So I've created a silly, simple thing. In this code, I am looking for large values that are greater than 20. And again, don't think of this as just 6 numbers, but I'm looking for all the values and I'm going to print them out. So, it says before, it's going to run this 9. Well, if 9 is greater than 20, it's false, so it goes back up. 41, true, so it prints out 41, then goes back up. 12, false, goes back up. 3, false, goes back up. 74, true, so it runs this, so out comes that little print statement. Goes back up, and then 15 is the last one, and that's false. It goes back up, and the 4 says, we're done, and then we do afterwards. And so this is just the notion of having an if statement inside of a for loop, where we're sort of picking or choosing or selecting or looking for something in a large set of things that we're looping through. We can also
True.
I want to.
We can also do that, but let's type this out first. So search using Boolean variables. Let's do that. All right. Boom. All right. So let's do that. Search using Boolean variables. Using a Boolean variable. So true or false. All right. So we're going to start off here. And let's see. We've got anything that looks like, I guess this kind of looks like it. So let's just take it from the end of after to the end of the P on this line. Whatever we want, wherever you can get it. Anyway, so like that, drop it off like this, pull this stuff back. All right, so we're going to say right here, drop it down one, bring it over to one time, I should say. Found now equals false. Found now equals false. Capital false. That's how Python does it. All right, so we're going to print before, and then we're also going to print found. All right, we're not going to be using any of these. This is all going to be, actually we'll use this. So copy this. No, copy this with the dollar sign. Copy that, bring it back to, drop it off on this line here. The top line is, ooh, it looks like we're two above the top. Let's drop it off right here. All right, let's say Python search.py right there. And then bring this over here. So we're going to first print out before and whatever found is. So before, and now found is false. All right. So now let's get into the loop part. Get out of here. Get out of here. Get out of here. Get out of here. All right. So now we're in the loop part. So for value in 9 in this list, if value is greater than, no, we haven't even done this yet. So if value is greater than 3, let's get rid of this. Get rid of this. If value is greater, double equals 3. So if value double equals 3, all right, we're going to say down here, found now equals true. Okay. And then we're going to print. We're going to print here outside of the if statement, print found and value. All right. Yes. All right. And then we're going to print after and found when we're outside of the for loop. All right. So let's go through this again. Or for the first time, whatever. So if value equals 3, we're going to say found equals true. And regardless of what happens, we're going to say print found equals value. All right. So we'll start on the first one. Does 9 equal 3? No, it does not. So we're going to say false, which is found, and the value, which is 9. All right. So the next one, we're going to look at 41. Does 41 equal 3? No. So we're saying false. The value is 41 that we checked. All right. So now we're checking if 12 equals 3. It does not. False, because 12 does not equal 3. 3. So does 3 equal 3? It does. Found is now true. So true. Found just got turned to true. We're going to print found and value. All right. So we'll say the value is going to be 3. But the thing is, you see, we're not turning it back to false when we're done. That's why the next one's going to look through and say, is 74 greater than, no, is 74 equal to 3? It's still not executing this code, but found is still true because we never changed it back. So it's still going to say true and 74, right? Makes sense because we didn't change it back. We did not tell our tool, the machine, to change it back. So it's our fault that it still says true. Again, when it checks 15, it'll still say true because we didn't change it back. That's our neglect. Our neglect made it look so ridiculous. Okay. And then we're going to say, we're done with 15. We're outside of the loop. And now we're printing after, and then we're going to say whatever found is, and found is true. All right. And so that's how that loop's working. Let's type these words down at the bottom too. All right. So if we just want to search and know if a value was found, we use a variable that starts at false and is set to true as soon as we find what we're looking for. All right. But the thing is, if we didn't want to have this nonsense afterwards, let's imagine that I didn't select that, but this one and this one afterwards, we could have put break after this. We could have done something like this. We'll still tap it over. We could have said break like this, tap it over one more like this, and it would have just broken out of the thing and said true is it's 3 and whatever. But we didn't do it like that. So let's bring it back to this. Oops. How about this? How about this? How about this? Nope. Whatever. It's not a text editor. Anyway, so there's that. Listen to I almost called him a doctor.
And no,
listen to this guy.
Value is there.
Let's listen to this guy with questionable intents and morals. Let's listen to this guy.
And so we're going to use a Boolean variable. And we've talked about integer variables like 1, 42, and then floating point variables like 98.6, and then string variables like hello world that have quotes in them. This is a fourth type, a kind of variable. It's called a Boolean variable, and it only has 2 values. It has true and false. Matter of fact, these if statements, they return Boolean values, value equal 3.
I was saying yesterday, larger looks like a stupid word, but then you look at this and you're just like, Boolean, baby, Boolean. Let's go out to Boo Orleans. All right, let's go.
3, that is returning a true or a false based on the value of value. There's a mnemonic confusion there, right? But I'm using it. So I'm going to make a variable called found, and that's a decent name for a variable, so don't get hung up on that. And I'm going to initially say found is going to indicate to me whether or not I found a 3 in my list. And I'm going to start before the loop starts, let's say false, because we haven't found anything yet. So found equals false. And so at the beginning of the loop, found is false. Before the loop starts, found is false. And now we're going to run this loop a bunch of times. 9, is that true? No, skip. 41, is that true? Skip. 12, skip. Right, so 9, 41, 12. And found has remained false because we haven't done anything to it. But now in comes a 3. And this becomes true, so it runs this code. So found becomes true, and then we print it, and you'll notice that when we see a 3, we get true. And then it runs again, we get 74, it's still false. 15, it's still false. Run, quit. And the residual afterwards is true. And in fact, if you didn't know any of this, and you don't print that out, all you know is that afterwards we loop through all those things, and we know that there was a 3 in there. That's what we're doing. So we searched all of them, we checked for 3s when we found a 3, and you can see basically that, the found remains false until it flips to true, but then there's nothing to set it back to false. There's nothing in this loop that's going to set it back to false. So once it sort of catches the 3, then it remains true for the rest of the loop, and then it just finds its way out. Now, if you want to think about it for a moment, ask yourself, how might we make this loop more efficient by putting a statement right in here? Think about a way to, once you found it and it's true, there is sort of no reason to keep on going.
The break statement.
What would you put there to perhaps make this loop to look for 3s, just to tell you whether or not there was at least 1 3 in there, how to make that more efficient? Just think about that.
Quit.
Okay, so.
Wait, are you not going to tell us? Whatever, you know what to do. Look, good thing you're watching this video. The old code man sets you straight. I'm going to just say, here's a cliffhanger. All right. Although maybe that would get me more views. I'm not kidding, but at the same time, that's a lot of, this stuff that I'm doing, I'm building routines here. You know what I'm saying? And adding to a routine, that's hard work. I'm not trying to do that. How to find the smallest value, right? The thing you need to know about the code man, okay? Look, I've had a lot of hard jobs, crappy jobs, jobs, right? That's why I say it like this. Either get your hands on the keyboard or get your hands on the shovel. Because you know what? If you want to get a paycheck from shoveling dirt from one part of the ground to another, you can do it. But I'd rather do it the easy way. All right, let's do this. So largest so far, -1. All right, so let's go get our largest so far. Where are you? Right here. Let's take it from the 4 up to the E in value. All right, take that, bring it down here. Droppity drop. All right. So the question is, how would we change this? Let's add it above instead of below. So let's say, how would we change the following code to make it find the smallest value in the list? How would we do that? All right. So let's take care of this business first. So let me get rid of this stuff while we are at it, because it's not going to, after we change it, it's not going to equal the same stuff. All right. Or maybe it actually will. Well, whatever. It's already gone. It's gone is gone. I'll retype it. And get out of here. Okay. So how would we change this? So first, let's change it from largest to smallest. All right. Smallest. How would we change the following code? So smallest. All right. So let's call largest so far. Let's call it smallest so far. Let's take the E. Let's take the larg and turn it to small. All right. Let's copy small because we're going to change it up a few places. Let's take larg here. Get out of here. Get out of here. No. Get out of here. Get out of here. Get out of here. And get out of here. All right. So print before smallest so far. We can do that. All right. So let's do the print first. Let's say before. And the smallest so far right now is -1. Here's the thing. -1 is going to be smaller than anything we put in there. So we're going to have to say something different. Now how would we do that? Because what if the number's infinity, right? What if the number, what if the number is infinity? Can we just declare it up here? All right, let's smallest so far equal -1. We can have that equal -1 for right now, right? So first we're going to come over here. No, that wouldn't work either. What would we do? Because we have to start at a big number, right? Smallest so far. How would we do that? How would we do this? Smallest so far. We'd have to start at a big number, right? Can we just declare variables without anything in there? Can we say infinity right here? Is there an infinity word, number, word, whatever? Hold on. Is there an infinity value in Python? Way to represent infinity. Inf, float inf. Okay, so this is what we would do. Let's say float inf like this. All right. Let's come over here. Let's come back to our thing. All right, let's embiggen this. It's so stupid. All right, let's call it float inf like this. All right, so now we've got infinity right here. All right, so that makes it a lot better. So we've got float infinity. So what would it print? What would, well, let's find out what float would. What would that print? What would this print? If we said, oh, here we go. It would say inf right here. Okay. So if we print this out, it would be inf. All right. So let's come back over here. Let's do this. Let's open this. All right. So when it prints it out, it'll say inf to start with. Okay. So now we're going to print before smallest so far. Yes. Okay. So smallest so far is infinity. All right. So it checks this. If the num is less than, so let's change this to less than, smallest so far, we're going to say smallest so far equals the num. Right? Right. So it looks at 9, and is 9 less than infinity? It is. So we're going to print out 9, and we're changing it to 9. 9, and we're changing it to 9. Right? So the next line down is 41 bigger. No, it's not. So we're going to say 9. We're going to say 41. We're going to print smallest so far, which is 9, and the num, which is 41. Okay? Then on this one is 12 less than 9. No, it's not. So we're going to say 9 and 12. Okay? So the next line we're saying is 3 less than 9. It surely is 3 and 3. Okay? Is 3 less than 74? Of course not. 74 right there. 3 less than 15? Nope. All right. And then on this line, we're going to print after and smallest so far. After and smallest so far. After, smallest so far. 3, boom. So that's how we would change it. Now, how he's going to change it, we'll see.
Look back at the largest value. Okay, so now let's look back at the largest value that we started out with, right? And so if you think about this, let's kind of give it a sort of a rough look here. Largest so far is our kind of like a running total, but it's our hypothesis is the best large number. And we have this if statement that says if the number we just see right now is greater than the largest so far, then capture it, right? Take whatever number we saw and capture it. So when we see 9, it's better, we capture it. We see a 41, it's better, we capture it. We don't capture this, we capture the 74, and we don't capture the 15, and that's how we do it. So you could think of this as better. When the number we're looking at is greater than our working hypothesis of the largest, we grab it because it's better. So this line right here is the grab line. Grab it. Okay?
Sure.
So then the question is, how would you modify this code to teach it to find the smallest value in this list of numbers? Think of it as you have a starting number, you have a sort of what's better in this grabbing notion. How could you do that? Take a look. Okay.
Man lives next to the tracks.
So let's do a couple things. Like if you look at this if statement that's better, well, it's better now if the number is less than. So but then we should probably change this to be smallest so far, 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 right?
True.
Matter of fact, that's what this is. We've changed the word largest so far to smallest so far, and we've changed the greater than to a less than. Is that going to fix it?
No.
I'll give you a second to look at it. Pause if you need.
No. Smallest so far can't be negative 1.
Find our smallest number.
Nope.
The answer is, of course, no.
Of course not.
It's not. So if we run this code, so we set the small so far to -1, and it starts out -1. We run it.
I don't think we need to write that down. Actually, let's write that down. We switched the variable name to smallest so far. No, we already went through the whole thing. We don't need to write this junk down.
And it's 9. Is 9 less than -1? No, it's not. So after we see a 9, the smallest so far is -1. Now we're going to run 41. Is 41 less than -1? No, it is not.
How many minutes are we going to go through this obvious thing?
-1. As a matter of fact, it isn't the smallest so far anymore. Just because we named it smallest so far doesn't mean it is the smallest so far.
Okay.
We're going to the next part. And then lazy. What? How long way? 10,000 or far? Because what we have. What we do.
None. What? Hold on. Hold on. We're gonna ask ChatGPT. Let's take this. All right. Let's take this. Copy it. Bring it down here. Take all this. Get this out of here. All right. We're asking ChatGPT. I don't care. All right. Oops. Oops. All right. There we go. There we go. There we go. All right. ChatGPT, where are you? Will this work? Let's say this. Will this work? Yes. Yes, it will. So, there we go. So we could have done this. Well, hold on. What are we doing here? All right, let's read this. Should we? I don't know if we want to type this out because the way we did it was more efficient, right? And all we had to do was look up ChatGPT to find out what this guy wasn't telling us. That's what I feel. But let's look at this anyway. Finding the smallest value. We're not typing this down. All right, smallest equals none. Print before. For value, blah, blah, blah. If smallest equals none, we're going to say smallest equals value, okay? So we're going to check to see if smallest is none, and then we're switching it to whatever the value is. Else if value is greater than smallest, we're going to do smallest equals value, okay? So it's basically adding this part right here. What did ours look like? Oh, I guess, look, we can type this out. We can type it out, but we need practice. All right, so we got this already, and let's just change it to this. So smallest so far, we're going to keep it smallest so far because I don't want to change everything. Let's call it none, all right? All right, so we're going to say if, we're going to turn this into an elif, elif, all right? Oops, drop it down, 1, 2. All right, right here, we're going to have if. Smallest so far. Let's get this. If smallest so far is none, I guess we can say is none. All right. Let's call this none. None. All right. Is none. I guess that's a way we can do it. I don't remember learning about is, but all right. I was going to say double equals none or whatever. Smallest now equals the num. All right, we're not changing up that stuff. Smallest now equals the num. Smallest so far. Not bad. All right. So actually, let's change it all up to look like that, just to avoid confusion on anybody's end. So we're going to just print before. All right. Smallest so far. All right, get out of here. The num. We're changing that to something else too. Value. Let's turn that to value. Copy that. The num here. Paste. The num here. Paste. The num here. Paste. Smallest value. Okay. Smallest, get this out of here. And then turn this and turn this. What a pain, right? But this is part of it, right? All right. So for value in this, true, all right? If smallest is none, right? We've got the colon here. We're going to say smallest now equals value. Elif value is less than smallest, we're going to say smallest now equals value. I'll print value, and then we'll say pretty much the same thing. So we'll come over here and we'll do $. Do I have to write this down? Python smallest.py. I have to review all these too when I'm editing to make sure I didn't say anything. I mean, clearly you can see some of my stuff is stupid, but I have to make sure it's not completely ridiculous. All right, so that's not 9. Let's put 9 here. All right, the smallest value we're going to have. All right, so we know what's going on, right? So if smallest is none, we're going to change smallest to value, right? So we changed it because at the first time we went through, right? Let me start at the beginning. So we're going through print before. We printed before. For value in this, if smallest is none, we're going to say smallest now equals value. Smallest on the first round is none, so we just changed it to value. Elif value is smallest, we're going to do this. So we did this, and we're printing smallest and value. So we changed smallest to value. Okay, so smallest now equals value. So smallest and value are now the same. We're printing smallest and value. So 9 and 9, right? Smallest is 9, value is 9, all right? So we're going to come through again. Is smallest none? No, it's 9 now. So elif value is less than smallest. Value is now 41. Is that less than smallest? Smallest is 9. No, it's not. So it's going to still stay 9, right? So we're going to the next one. Is 9. All right, so is 9 none? No, it's not. If value, which is 12, is smaller than 9, which it's not, we're going to change it, which we won't. So we're just going to have 9 and 12, right? Come down here. We're going to come down again. Smallest is still 9, so we're never going to have to do this one again because we already changed it, right? So I'm just going to skip this. We're done with this. Skip it. Is 9 less than 3? No, it's not. So 3, so we're changing smallest to 3. And we're going to say the value is 3, right? So value is 3. Pardon me. So smallest is 3, value is 3, right? Of course. So skipping this one, we already got it. So we're saying, is 74 smaller than 3? No, it's not. So we're going to say 3, and 74 is not smaller than 3. So is 3 less than 15? Nope. And then we're going to print out after smallest, all right? Did I miss one? 9, 41, 12, before smallest. After 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know why that doesn't line up, but it doesn't. Anyway, whatever. So that's how this works. Did I miss a thing in here? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whatever. All right. So that's how that works. Let's write this down. I told you it was going to be an hour. And we're not even done yet. We still got 6 more minutes of this thing. So we still have a variable that is the smallest so far. The first time through the loop, smallest is none. True. So we take the first value to be the smallest. Okay. True. Let's listen to him talk about it.
Is we use yet another type. So we have integer, floating point, string, Boolean, and now we have a thing called a none type. None type is a special marker in that it only has one value. Boolean has true and false. You know, floating point has an infinite number of values, and integer has an infinite number of values, but none type has one value, none. None is a constant. Capital none is a constant.
True.
The difference is we can check to see if we have stored none. None is often used to indicate emptiness, not non-existence, because smallest doesn't exist until we assign it, but we're going to assign it to like a mark, a flag, a marker, some way to say, oh, this is not even a number, it's nothing. And so we're going to, and you can do this. So that's like makes a variable called smallest.
It's something, but it's not nothing, right? It says none, but it's just a placeholder. I think that's all he's trying to say. It could say placeholder, but none is easier to write. So there we go.
And in it puts none. It sticks it right in. It's not a string none, it's like a special type.
Like a placeholder.
Okay? So that actually captures the notion that before the loop starts, the smallest number that we've seen so far is none. We haven't seen any numbers. Okay? So then we come in and we have an if statement. And we have a new operator called is. Is stronger than equal sign. And so if smallest is none, that becomes true. It runs this case. And so then what it does
I've got a question though. Let's ask the expert. Is none? Hold on. Is keyword in Python. Wait. Delete. Do the is keyword in Python and the double equals operator or keyword, whatever operator thing, let's just call it thing, equal the same thing. Let's see. Is do not mean the same thing. Okay, that's what I mean. They serve different purposes. The equality operator checks if the values of two objects are equal. It checks for value equality, meaning it checks if the values stored in the object are the same. It can be overridden in user-defined classes by using the EQ method. Okay, that's something we didn't need to know. Is the identity operator. The is keyword checks if two objects refer to the same object in memory. Okay. So it's not like, they're talking about the exact thing, like the exact same. You see what it says. It checks for identity equality, meaning it checks if the objects themselves are the same, i.e. they occupy the same memory location, right? So if the thing is, I don't know how to explain it because I just learned. To summarize, use double equals when we want to check if the values of two objects are equal. Use is when you want to check if two references point to the same object in memory. Here's another example, even better. X is 1,000, Y is 1,000. Print X is Y. All right, and it would give us true because they are equal. Print X is Y, it would be false because X and Y, even though they equal the same thing, they are not the same places in memory. So if Z equals X, if we make another one called Z equals X, and if we print X is Z, it will give us true because X is Z, because Z is X, right? Right? Yes. Perfect. That's what we needed to know.
Copies this first value, which is 9, into smallest. And so we see a 9, and the smallest so far is 9, which is the first value. And again, we're assuming we don't know what the first value is before the loop starts, so we use the first iteration through the loop as the moment where we capture that. Okay? So, smallest is the value, and then we print it, and we go back up, and now it runs again with 41. 41 is not none. None is, there's only one thing that's none. So it is not equal to none. Smallest is not equal to none, or is not none. So this is false, so it skips over here. Then it asks the question, is the value we're looking at 41 less than smallest? Well, smallest is 9 in this case, and this is 41, so that's false, so it skips that and goes on. So we see 41, we don't take it, and then you can see that this will never become true again. This is pretty much false for the rest of the iterations of the loop.
True.
That's false for the rest of the iterations for the loop. So it just is going to run down here and ask this question. And at some point we see a 3, and we run this code, we capture it. We see 74, we don't capture it. We see 15, we don't capture it. So then the for loop skips out. At the end, we have the smallest. And actually, this would be a good technique for the largest as well, because it really is just a technique to put a marker in this variable so that we snag that first number or first whatever as we read and parse through them.
I think that that's true. Let's look at the thing. Let's look at the old notes. Yeah, so I think this way is better because then we can just switch this one. We could just change the signs and the smallest or largest or whatever. We could just call this number, honestly. It's number less than whatever, and it would work, right? We could just change the sign and it would be interchangeable. Whatever, all right, so let's keep going.
So the is and is not operators are...
Oh, man, that's a lot of typing. Can I stop recording and record later? Nope, that's not how the workflow works. All right. The is and is not operators. Man, I hope we don't have too much more. All right. The is and is not operators. All right. So let's do this. So that's the smallest thing. So let's get this smallest again. This one right here. Let's bring it. Let's get this empty area. And so let's take it from here to 3. From this 3 to this 3. All right. Let's drop it off here. Bring it back up. How about that? All right. Let's get rid of all this stuff. There we go. Python has an is operator that can be used in logical expression. Okay. So this is talking about the is that we looked up on ChatGPT. All right. So let's just type this out. Python has an is operator that can be used in logical expressions. All right. Let's skip 2. It implies is the same as. I think ChatGPT said a little bit better. Similar to similar but stronger. Similar to but stronger than the double equals. True, we've already figured that out. Or different, actually. Is not is not also. This is also a logical operator. All right. So this is not is the same as is the logical is not operator. Okay, hopefully that makes sense. This is not saying is not. You see what it's saying. All right. Let's listen to him talk about it. Let's listen.
Are very useful in Python. You can think of them as like the double equal sign that reverse through them. So the is and is not operators are very useful in Python. You can think of them as like the double equal sign. They're asking a question, and they return a true or blank is blank returns a true or a false. It is stronger. Double equal says are these things equal in type and value? So just as an example, if I were to say, is 0 equal to 0.0, it would say, yeah, that's true. But then if I says 0 is 0.0, that would be false. So that's because these two are the same value-wise, and these two are not the same type-wise. So is stronger than equals, meaning that it demands equality in both the type of the variable and the value of the variable, and no conversion is done. And so that's just
if it's like if you did the JavaScript already, I guess is just like triple equals, right? I guess that's what he's saying, basically. But ChatGPT said something different. Let's go look at ChatGPT. It's my video. I can do what I want. All right. So is the is operator just like the triple equals in JavaScript? Boom. Let's see. Yes, similar. Identity rather than equality. Okay. Anyway, it's going to keep typing. It's going to keep talking. I don't want to hear it.
Very strong. Don't overuse is. If you're dealing with numbers or even strings, use double equals. Don't use is, because sometimes it gets a little confusing. So use is sparingly. I tend to only use is on Booleans and on none types. I don't use is on integers, and I don't use use is on floats, and I don't use is on strings. Just none or true false. And also, is not is also an operator. So you just say blah, blah, blah is not none, or blah, blah, blah is not false. Okay, so
all right, here's the summary that he's going to just skip through. Or maybe we still got a whole minute. We might go through the whole thing. But anyway, let's type it down anyway. So let's do the summary. This chapter was kind of a pain, but we learned a lot, right? Summary. All right. While loops. Indefinite. All right. What did we do before on the last summary? Did we define it? Oh, geez, that was a long time ago. Okay, so we're going to define this stuff while we're at it. What a long video. I could probably do this for 20 minutes, I bet. All right. So while loops, these are loops that run indefinitely until we tell the loop to break for some reason. Oh, okay. Let's say that. How about that? Infinite loops. Loops that don't break. Loops that don't break, basically. Using break. Use it to break. Use it to break out of loops. Yeah. Using continue. Use it to break out of a current iteration of a loop, but to keep the loop running. But it keeps the loop running. How about that? Yeah, we'll say that. How about that? None, constants, and variables. All right. The none constant is basically a placeholder. All right. What else do we got? For loops. Definite. Maybe we should have did it like this, but whatever. Definite. So these are loops. These are loops that run a specified amount of times based on something we tell it based on a limit we provided. Oh, that's good enough, right? Iteration variables, right? The variables inside the variables that change throughout the loop, during loop iterations based on criteria we provide. How about that? All right. Loop idioms. Idioms. I don't remember what that is, so let's let him tell us. And then I guess we can look it up. Smallest value, loop, summing a loop, counting a loop. What we do in loops, huh? Even though these examples are simple. What? Loop idioms. Are those like different patterns? Different common loop patterns? Common loop patterns. We'll put a question mark at the end of that. And largest or smallest loop idioms that find largest or smallest I don't know, lists, whatever, or ranges or whatever. All right, we'll put a question mark on this one too, so he'll tell us. All right, let's go.
We've been looping around and doing loops and loops of loops.
Yep.
We looked at the indefinite loops, the while loops that kind of run for a while. The definite loop, and we looked at break and continue as a way to either escape completely from the loop or go back up and discard the current iteration of the loop. We looked at none. We looked at Boolean variables. We have for loops, definite loops, where you've got some kind of a set or a list or some kind of sequence that you're looping through. And then the concept of loop idioms, where you do something at the top, something to each item, and then you sort of get a benefit at the bottom.
What does that mean, though? Kind of like the structure of a loop? Loop structures? Let's say loop structures. We'll put semicolon loop, basic loop structures. Basic loop structures. All right.
And so that gets us through iterations.
All right. And we didn't talk about largest and smallest, whatever, but we did. All right, so there's that. So in the next video, we're going to do the exercise, and then we'll finish up with this stuff. So there's that for now. So now we're on to more resources exercise, and we'll see you next time.